So thanks, Steve, and welcome to our opening. I thought I'd just give you a little bit of the history of this and as to why we even thought it was a good idea. And it really, unless you've been asleep at the wheel, most people are starting to understand that we're entering an age of batteries and energy storage. Pretty much everything we take for granted these days has got a battery in it somewhere. And we hear a lot about lithium-ion, and in fact there's going to be a massive opening tomorrow that I'm sure you've heard about. But what people don't seem to take much attention to is the fact that the 800-pound gorilla in the battery world is lead acid. It's a fifth of the price of a lithium-ion battery. And it's 100% recycled. It's the only 100% recycled commodity on the planet. No other battery technology, no other material comes close to the level of recycling of lead-acid batteries. So we thought that was really cool. And then we looked at the way that lead-acid batteries were recycled, and we looked at the technology behind it. And there's an issue, and it's that the smelting is the default technology for recycling batteries. It's a high-temperature thermal process. It traces its history back nearly 6,000 years. There's a lot of hard-working guys trying to make improvements to that technology, but outside of the US, it's poorly or sometimes barely regulated, and it's just technically very, very difficult to recycle a battery using smelting without either making an environmental mess or spending a fortune to stop making an environmental mess. So 3 years ago, after nearly 2 decades of work in the battery industry, I came up with this crazy idea, which is, why don't we think of a better way of doing this? So we set out to do it. Basically, Selwyn Mould, Tom Murphy, Mike Hurwitz, my dad, and Dio and Mick and a few others pitched in and came up with a process. But actually what we really started with was a whiteboard and a series of questions and a series of requirements. And the first one was, it has to be cheaper, fundamentally cheaper than smelting. I've been an environmentalist most of my life, and what I've seen that works is breakthroughs that are economic and self-sustaining, not by regulation. So the first point was, this has to be significantly cheaper than smelting. The second point was, it has to be a zero-emission process. And the third point was, it needs to be widely adoptable and relatively easy to permit. So we set out to do it, and I'm not going to spend too long talking about how we got there, but within 6 months we had an operating prototype. And then we got invited to the Secondary Lead Conference in Shanghai in September 2013, when we just had an operating prototype. And I thought it'd be a good idea to see if the lead industry is going to be responsive to this new technology. So I presented at the second day of 2 days of listening to smelters talk about smelting, and I walked on the stage with my little shiny presentation and realized that I was about to tell a room full of people that a $22 billion industry is about to go obsolete. So I voiced my concerns as I got on the stage and said, you know what, guys, if I can get off this stage in 20 minutes in one piece, I'll think it's a win. And what I actually found was, smelters don't smelt because it's their religion. They smelt because they're lead guys, and it's the only tool they've got in the toolbox. And we were absolutely swamped with interest. I literally had $200 million of indicative interest to buy AquaRefining equipment, and all we had was a tiny little prototype. So we then set out to raise some money, did the usual thing, got told to go away by Silicon Valley more times than on one account, by 23-year-old MBAs. Well, these are gray hairs. So we came across an outfit called Liquid Venture Partners, and my good friend now, Dan Landry, came up to see us. And bear in mind, these are bankers, and I've got a lot of experience with bankers, and this is what never happens. You never ever take a banker to your technology and show them it, and they respond with something like, oh, cool, you're doing coordinated electrochemistry and making lead nanofibers. And we went, what? You're hired. And 3 months later, they set out, well, actually, they set out straight away to raise us $4.5 million. 3 months later, they'd raised us over $6 million. And that set us on a path to build our first full-scale unit, which we returned the favor and had our first full-scale unit running 3 months later. And that set us on a path to do an IPO, which we completed last summer. And we cut ground on this just 12 months ago, and we're going to see what we've built. So the interesting point is we spent a lot of time thinking about the business model because we're really serious about generating a viable, economic, and advantageous alternative to smelting, and that's what we think we've done. So we're going to take you through this in groups and show you the process. We're quite happy to explain the process in detail. One of the things that we've been keeping a little bit secret is the fact that that first comment that Dan Landry made, you're making lead nanofibers. Well, actually we are. The trouble is the market for lead nanofibers is not quite here yet. But the interesting thing about lead nanofibers, and if you saw the video that's playing as you walk through, and please go back and take a look at it again, what you'll see is a machine that's got a rotating disc that's plating lead onto it in the form of nanofibers and then pulling it off continuously. It's a fully automated continuous process. Those fibers can be compressed into a block of lead at room temperature because they are nanofibers. Okay. The problem is there's no market for that either. So what we're actually doing is turning them into lead ingots to sell to the lead industry because that's what the lead industry wants. But there's a lot of research going on right now looking at advanced lead-acid batteries, and one of the hottest areas of research is to replace the micron-scale active material with nano-structured active material. And what you get is pretty much what the lithium guys found when they went from micron to nanoscale. You get a massive increase in performance of the battery, higher cycle life, more material utilization, and the rest of it. So we're now going to start talking over the next few months about a long-term plan to move from just making lead ingots to actually making high-performance active material for batteries, and maybe even fully formed plug-and-play electrodes for the lead industry, because we think we can materially impact the performance of lead-acid batteries and take it to the next level, and that's a really cool thing. So, but we're starting off real simple, making lead ingots and providing them to the market. So that's a bit about the technology and the background on why we're doing. What I've really got to do now is say thank you to the people that made all of this possible. And one of the people, or one of the companies we met at that show in Singapore was Wirtz Manufacturing. Rob Wirtz saw it, came to see what we had, brought his dad down, and they became our first strategic partner. So most of what you're going to see in here at the front end is equipment that Wirtz Manufacturing have made and shipped here for us. They are now our strategic partner in supplying the front end of the equipment that we provide the Aqua refining to the back of. The second group I mentioned earlier, Liquid Venture Partners, believed in us at an early stage and gave us a response that you don't get from Sandhill Road. They've been phenomenal. They've been really supportive. And then Alex Lewis and his business partners at North Avenue Investments brought in the USDA and Sarah Adler and a team who shortly after the IPO provided a loan guarantee for $10 million, and then our friends at Greenbank turned that into a loan, so that's helped us as well. We've talked about, Steve mentioned Battery Systems Inc. I'd like to say that we built our facility next to theirs on purpose. Honestly, it was an accident, but it was a phenomenal accident, and we're going to do it again. One of the things that we can do that you can't do with a smelter is co-locate with the company that collects the batteries. So that's kind of what we're doing with Battery Systems Inc. and Interstate. There's 1 million people that we need to thank beyond that. I've probably missed a bunch out. I apologize if I have. Someone's going to talk about the people we've worked with from an engineering and contracting and building standpoint. So that's basically all I have to say, and I'll get out of the way and let somebody else talk. Thank you.